Software damaged by AI has hurt almost every company on the planet. But the impacts on your software could be even more catastrophic. Let's look at how AI hurts software. Now, every action you take has a cost. Too often, we look at the benefits of an action and forget to look at the drawbacks. In this series, we're looking at the costs associated with AI in various sectors in order to have a better understanding of what we're giving up in order to gain the benefits of AI. Now, if you want to support this channel and the free content that I produce, consider purchasing one of my courses at imtimcorey.com. I have master courses on C#, web development, and game development with Unity, as well as training courses covering a wide range of topics. The income from those sales directly funds the free content that I create here, including videos like this. So let's look at how AI can hurt your software. We're going to start off with something we've seen quite a bit recently, but I want to touch on. This is the GitHub uptime. This is where really the impact of AI starts, because almost every company on the planet uses GitHub to store their source code. Not every company, but a lot of them do. And even the ones that don't usually have dependencies that live in GitHub. So GitHub is right now under really siege when it comes to AI, because there's so much code going into GitHub, so many new pull requests, so many new commits, so much new GitHub action processes running on that code that it's almost like a distributed denial of service attack against GitHub itself. And so just that alone has caused this downtime. Now, when I say just that alone, I mean that on its own will have caused a lot of downtime. However, I will not say that's the only cause or the only problem that GitHub has. I am fairly well convinced that it's also bad code written by AI that's caused more problems with GitHub. But that's beside the point. Just to start off, right now we have a problem where GitHub is unreliable because of the pressures of AI, which has a ripple effect on getting new versions of your dependencies, on fixing bugs, and just on trying to deploy your own code because of what's going on at GitHub. But that's not really the only thing. But before we go on from GitHub, which we've covered in enough detail, I don't need to go into more details here. But I do want to point out the uptime. So right now, the uptime as of May 7th is 84.35%. That's a cumulative uptime over all their services. To put this in perspective, because too often we see percentages and say, well, an 84% is still a B, it's still a passing grade, it's probably fine, right? Or you don't really kind of comprehend what that means. So let's put this into perspective. Imagine for a minute that GitHub had 100% uptime for most of the year, and then they turned off their servers when they reached 84.35%. What date do you think they would turn their servers off? Well, that date is, that date right here is November 5th. November 5th is when they would turn off their servers. That means that from November 5th to the end of the year, GitHub will be down entirely. That's how much downtime GitHub has been experiencing over the past 90 days, amortized over the whole year, right? So if we say, hey, let's extrapolate out and say that 84% is for the entire year, which it seems to be going down, not up. It used to be 88, then it was 89, it was 90. Like it's gone, if you go backwards in time, it looks better because it gets higher and higher. But as you go forward in time, it looks worse and worse. But if we just said 84% over the course of the year, they would basically be turning off their servers November 5th and not turning them on again until January 1st. That's an enormous amount of downtime. Now, not every service is down. Different services are up and down at different times, but this doesn't even seem to truly reflect the actual downtime, because there's been more downtime that's been poorly reported, where GitHub will say, no, our servers are entirely up, but they'll also say, yes, we had downtime outages today. So even this number is suspect as maybe being too high. This is a reflection of where we are as a society with AI. And just this alone, forget your code for a minute, just this alone is having a major negative impact on the software development market. But let's go more into how it can affect your code specifically. To do that, let's look at this. And notice down below there's links to all these articles I've pulled from a number of different sources. What we see on the web today is that everyone has an opinion, and too often those opinions slip into any news article you read, or any poll you read, or any even a study you read. So be very careful to pull from a wide range of sources and verify these things and really make your own conclusions. Don't just think, you have a conclusion, then fit the articles to fit your conclusions. That's not how you do good research, but you should have a wide range of sources you pull from and think through, is this logical? Does this have a slant? Is there more that I can think about? Okay. So I have done that, but I want you to do the work too. So I have linked to every one of these articles. I just pulled out pieces from these. I don't agree with all these articles and what they're saying, but I think that there is some nuggets of truth in everything that they're putting out. I wouldn't give you bad resources. I think sometimes the conclusions of these articles aren't the best, but I think that the data they provide does give us a good picture. So this first one from Fortune, an AI-powered coding tool wiped out a software company's database and then apologized for the catastrophic failure. So this is from July 23rd of 2025. I'm going to mention that because all of my articles are recent articles, but we're going to see why it's important to know where these are coming from in just a minute. So this is from Replit. An AI coding agent from Replit reportedly deleted a live database during a code freeze. So the developer said, hey, we're not going to change code right now. And the AI said, cool, no problem. I just dropped your database. That's okay though, right? And it admitted to running unauthorized commands, and it violated explicit instructions. This is one of the things we have to understand. We talk about AI is we try to treat AI both as a person and as a machine, and we really mix those two up too much. So we treat it like a person in that we think that it can think, and we can think that it has reasoning, and we tell it to do things and expect it to reason its way through to the conclusions. But we also treat it like a machine in that we think it will always do the same thing the same way every time, not reason and change its mind or fail to do the right thing. And that's problematic because neither of those is a good analogy for what AI is. So it violated explicit instructions. In fact, for this particular article, you can go read again more about it. It talks of the fact that they even went to, I believe it was OpenAI, or maybe it's Claude, I'm not sure. They went to the company and said, hey, can we have more explicit instructions to make sure that this AI doesn't violate what it's supposed to do? And they got more explicit instructions. And they have this whole instruction document about what you can and cannot do. And the AI still ignored those instructions in certain circumstances. Not all the time, just once in a while. So what we're really realizing here, what you should realize, is that whenever you give an AI instructions, when you give it a markdown file and say, these are non-negotiables, you cannot change production, those are all suggestions. It does not matter where in the stack you put that. It does not matter how many, all caps you use or how many exclamation points you use. It does not matter. The AI will treat that like a suggestion. In fact, what we found is that AIs actually do better when you give it less instructions like that, because they don't just learn from more of the instructions. They actually treat it like a junk drawer, and things get lost in there. So this is, kind of setting a stage for what AI can do for your software, or can do to your software and to your environment. In this case, it wiped out production. Now, should it have had access to production? No, of course not. But this person didn't even realize that it had access to production. But let's move on, because I'm sure this is an isolated incident. How I dropped our production database and now pay 10% more for AWS. You might say, wait, that's the same article. It's just from a different location. No, it's not. This is a different person. This is Alexei Grigoriev from March 6th of 2026. Talks about datatalks.club and how it got wiped out. So he was overly reliant on the Claude Code agent. And by the way, this is latest Claude Code. People tell me all the time, well, yeah, but the latest models don't do this. This is one of the later models of Claude Code. I believe it was 4.6, Claude Code Opus 4.6 that did this. Accidentally wiped out all the production infrastructure for their management platform that stored data for 2.5 years of submission. And all automated snapshots were also deleted. Now, he paid 10% more for AWS business support, which restored the database and brought everything back online in 24 hours. So this system was down for 24 hours, and he feels fortunate because of his usage of AI. And it's the fact that it did things it wasn't supposed to do. But again, that's just 2 incidents, right? Well, how about this? AI confesses to why it went haywire and deleted a company's database. This is from the New York Post. Again, third company. This is Pocket OS. This is not the previous ones. Okay, this is from May 2nd of 2026. So according to the Post, AI coding agent, again, Claude Opus 4.6, it went off the rails when it encountered a simple credential problem. Okay, so it has a credential problem. It said, hey, I can't do this. It went out and found credentials in a system that they didn't even know was there. Okay, notice that last line there, a programming token that no one at Pocket OS knew existed. And as a result, it wiped everything out. Crane lamented every layer of this failure cascaded down to people who had no idea any of this was possible. This is the danger of letting AI loose in your software development environment. It is a risk to your software. It is a risk to your environment. So these kind of things are not uncommon. They happen frequently, and they're happening more frequently as we go. So this is the kind of things that AI can do if you're not really careful. So let's talk about this right here, which is the software quality decline, how AI accelerates the decline of software, AI software's decline. And I really think that this is important to note. This article is really good about pointing out the fact that software has been in decline. This is not something new. It's just that AI is accelerating the decline of software quality. So now this article has a idea behind it we're going to talk about called spec-driven development. We're going to talk about that in a minute, but let's dig into what this article says. I love this quote from Alexei. Generation is easy. Let's talk about code generation. Generation is easy. Maintenance is hard. Coupling, cohesion, run costs, reliability, that's all your problem. So what he's saying here is that when you generate code, AI generates it very easily, and you can generate a lot. And we'll see later on that the amount of code being generated by AI is increasing at a tremendous rate. But the problem is that that's not the hard part. The hard part is maintaining the code that is generated. So what we're doing is we're accelerating how much code we generate and creating code that's harder to maintain, that's more coupled, has more cohesion, has more run costs, and is less reliable. That's a problem. Now, what used to be a production impacting bug that happened once or twice a year can become a weekly occurrence. When we talk about our software, the end result of our software should be they want our software to support our business, right? We have customers that are paying for our software, or customers relying on our software, or our business itself is relying on our software. And when that reliability starts to struggle, what happens is that we have impacted customers. We have impacted our business. We have impacted the thing that makes us money. And when that happens, our company struggles. all because of our code struggling. Going back to the GitHub example, GitHub is down to 84% reliability, 84% uptime. And people are saying, large companies, people who have been on GitHub for a very long time are saying, we're looking at alternatives. We're looking at leaving GitHub. And GitHub was still is the 800-pound gorilla of the market. It is the thing that everybody points to. It is the place to put your source code. And yet customers, paying customers, large paying customers, customers that have been there for a very long time are saying, you know what, we're looking somewhere else. And that's without great alternatives. There aren't great alternatives to GitHub. I'm sorry, there just aren't. GitLab and all these others, they may get there someday, but they're not anywhere near where GitHub is right now. And yet people are saying, we'll take the pain and we'll take the inconvenience to go somewhere else. You don't want that same thing for your software, because almost assuredly your software isn't as strong as GitHub is. Your software, if people say, hey, you know what, I have an easy alternative, there I go somewhere else. So a production impacting bug that used to happen once or twice a year, that's still a big deal, but now it's weekly. That's a major deal. Our customers need to depend on us, because if they can't depend on us, they're not going to be our customers for long. Now, this is where they lean into the idea of spec-driven development. And I wanted to highlight this really briefly because this is seen as the solution for AI problems. The idea that AI goes off the rails and we need to have better specs. We need to have better specifications that say, this is exactly what I want to happen. I heard one person say that they write a 3-page spec on exactly what the software should do. And they were in our 2 or 3 pages of UI testing and saying, these are the things that should happen. If I click this button, this is what should happen. And they specify this all in this report that then they give to the AI and say, hey, this is your spec. And that's the idea is, if you are clear enough, if you have enough clarity around what you are saying, you'll get a better outcome. Here's my pushback on this, because the idea is, well, eventually you get the AI to, box it into a corner where it can't do the wrong thing. But as we saw earlier, it goes against what it's been told and deletes databases. It goes against what's been told and it drops infrastructure and it changes things and wipes things out. Well, then what difference does a spec-driven development process going to be? Because yes, we have a more clear spec, but that just means that we have something to point back to and say, yeah, you made a mistake here. And the AI will go, you're right. I was wrong. Okay. So that's one thing. But also, the English language does not do a good job of clearly and unambiguously specifying a problem or a solution. There's just too much ambiguity. Do you know what you really need? You need to have a language that's unambiguous, that is very clear as to what the specification should be, and that you can know for certain that that specification is going to be the same every time. If you build 3 apps off it, it's going to be exactly the same. It's almost like we need a separate language for that, like a programming language. Because really what spec-driven development comes down to is we're basically trying to recreate the entire application in plain English to then have the AI then take that and turn it into code. And most developers I know don't like to write term papers, to write reports that then get turned into code. That's not the fun part of being a software developer. That's kind of a slog. And the reality is it's very hard to write that in English in an unambiguous way. Well, what we're doing is we're saying, hey, we're going to do all of this work and more of this work until you finally get to the point where you forced AI into only one possible solution, and that is to write the code correctly, which we know it won't do. but not all the time. It'll do it 99% of the time, just not all the time. But after all of that work, we're going to be putting in more work than just writing the code. Okay, that's what this is telling us. Let's keep going. Let's talk about the systemic failures in AI coding. This is from the new stack. Again, links down below. So AI systems do not understand. The new report flags systemic failures in AI coding. Here's a quick highlight from this. This is where I love the viewpoint people have on AI. It's making developers dramatically more effective. Hold that thought for a minute. Hold that in your mind. Dramatically more effective. Okay? But it's also introducing more security vulnerabilities, increasing technical debt, and producing code that can be difficult to maintain. Now, where in that sentence is it clear that software developers are dramatically more effective? It doesn't seem to be more effective. If I more effectively create more security vulnerabilities, increase the technical debt, and make the code that's harder to maintain, that's not more effective. That's just more code. And what it comes down to is people are trying to say that more effective equals more lines of code. And we have fought before AI. We have fought for years that lines of code do not equal more or a better developer. If one developer writes 10 lines of code and one writes 100 lines of code, that doesn't mean the one that wrote 100 lines is 10 times as effective. In fact, they may have solved the same exact problem, one more efficiently than the other. So lines of code has never been a good measure of being a software developer or being an effective software developer. And yet, what this is saying is that AI is making developers dramatically more effective, while at the same time acknowledging that effectiveness is actually creating security vulnerabilities, increasing technical debt, and producing code that's hard to maintain. That's something that when you start looking at that, you go, wait, that doesn't seem right. Let's continue in this article. One of the most striking observations found is that AI coding platforms have been observed to modify, disable, or outright delete failing tests rather than fix the underlying code. These AIs are doing things that violate what they're told to do because they're taking shortcuts because it works, because they don't actually evaluate anything. They're not thinking processes. Remember back in this previous set that AI systems do not understand. We try and give them human-like characteristics. They're not human. They don't understand. And so they modify, disable, or outright delete failing tests rather than fixing the underlying code. The result is that code that accumulates technical debt at scale, is over-engineered and redundant, and is increasingly difficult for human developers to review. Where in there do we find the value? Where in there do we see that developers are more effective? What we're seeing instead is that it's creating a whole bunch of junk that's hard to maintain. The quote down here, AI systems do not understand what they're producing, and they're not capable about reasoning about the consequences. AIs talk like humans. They're not. So we saw those articles about the AI deleting the database. It would say things like, "Oh, I'm sorry. I made a mistake. I was wrong. I lied to you." These are all things that are associated with human behaviors. It's not a human. It's not capable about reasoning. It doesn't know what the problem is. It just knows that you didn't want that. And so it's parroting back to you the response of, "Oh, you are right." So AI is causing systemic failures in coding. But let's keep going. This is the AI Acceleration Impact Report, or the AI Engineering Report from 2026. Again, this came out April 12th of 2026 in the links down below. So these are 10 takeaways from the AI Engineering Report. I only pulled a few of them out, but I first want to start with this chart here. So this is what I've been talking about. Output is up. So epics, the size of features or capability in the hundreds of tasks, 66.2% epics completed per developer. That's significant. By the way, this report was based upon 22,000 developers over 4,000 companies, just so we're clear. So the number of tasks, 33.7% task throughput per developer. These are huge numbers. The pull request merge rate per developer is up 16.2%. And I find this last one really fascinating. 861% increase in the code deletion ratio. So there's a whole lot more code being deleted, which they point out in this report. You should read the whole report. It's fascinating. But they kind of attribute this to the idea that there's three different reasons for it. A couple of them are okay. Like the fact that maybe we're getting to the point where we're refactoring code that, we wouldn't have spent time to refactor, but now we can have AI. And so we're doing things that we should have to clean up the code and make it more efficient and to be less verbose. That's great. But really what we're finding is that the other couple of reasons include the idea that AI is creating redundant code, which goes into production. We find out later it's redundant code, and then we eliminate that redundant code. So we're undoing a lot of things that the AI has been doing. And also that the AI writes a whole bunch of code. It's very, very verbose. And we look at that code and go, this just shouldn't be this verbose. And we remove a lot of the stuff. This is the review process of going through and deleting some of the things. And the problem is that we are reviewing this maybe even after it goes to production. But output is up. The overall idea is that output is up. So that feels very good. And really, it feels like success when it comes to AI. This is worth it, right? If AI allows us to complete 33.7% more tasks per developer, that's huge. That's like every 3 developers, you're basically getting a free developer for the year. Like that's a big deal. But there's another side of this chart. Let's look at part 2 of this, which is the production quality. Now, you have to know how to read this because otherwise you might think, well, with more tasks being completed, with more epics being completed, with the more pull requests being completed, that you're going to have more problems because if you're doing 33% more tasks, you would expect to see 33% more bugs overall because it's just an even ratio, right? That's not what this chart is saying. So let's read this. Incidents per pull request. It does not matter if you have 1 pull request or 100. This is per pull request. The potential incidents, potential outages, security events, or customer-facing failure is up 242%. Again, that doesn't matter if you have more pull requests going out or not, because this is per pull request. So really, if you have, 16% more pull requests, then you're not only going to have the increase of 242% per pull request, but now because you have even more pull requests going out the door, you're going to have even more problems, right? So that's number 1. Monthly incidents is up 57.9%. Now, monthly incidents, that can be a relationship to pushing more code. So the more code you push, the more incidents you would expect. But again, as we're seeing here, the per pull request issue or incidents is going way up. When it comes to bugs, 54% bugs per developer. So the number of bugs per developer is going up. But here's the thing. They actually looked into it and said, well, these models are getting better. Like, Opus 4 or 5 and 4 or 6 were amazing. And so that really changed how software development is done. So therefore, the newer models would create better code, and therefore that should go down, right? Except that last year, it was 9%. So it's getting worse. The number of defects that cause the software to fail is getting worse per developer, not better. And again, the number of bugs per pull request is up 28.7%. So quality is on the severe decline. And it's not just because we have more output. It's actually independent of that output, quality is on the decline. It's this increased output just accelerates even further that declining quality. Okay, here's some of the headlines from this. Again, there's I believe 10 headlines. I pull a few of them out. I didn't pull all of them out. I didn't pull out a whole section that describes all of this. I encourage you to read the whole report. But number 5, bugs are accelerating, not stabilizing. So the idea that as we get better at using AI, as we get better models, as we get better tools, these things will stabilize. And the reality is it's the opposite. It's getting worse, not better. Number 6 in their impact report is AI made it easy to start work. It did not make it easy to finish it. So it's easy to get started. It's easy to create new code. It's easy to write out, build out an entire system with AI. But that's just the start. And that's the easy part. And it did the easy part, but it created a whole bunch of problems that actually made it worse and made it harder to finish. Number 8, more code is entering production with no review at all. With the acceleration of the amount of pull requests, the acceleration of the amount of code being written by AI, developers simply do not have the time to even read the code, let alone actually evaluate the code for quality. We've known this for a long time, that if you have a pull request that you're going to review from somebody else, and that pull request has 10 lines of code, you're going to carefully evaluate those 10 lines. You're going to evaluate if this is the right way of doing things, if there's a more efficient way, etc. However, if that same person gives you a pull request to review that has 10,000 lines, you're going to look at that and go, looks good to me. Maybe you're going to tweak a couple of formatting things or, easy off the top things, but you're not going to look at those same 10,000 lines like you looked at the 10 lines. You just don't have time, and it's not how we work as human nature. The problem is that AI is writing a whole lot more code. And because of that, a whole lot less code is being reviewed before it goes into production. Now, this report will actually point towards the idea of we need AI monitoring. We need to have AIs monitoring the code that's being written by AIs because that's going to solve the problem. And no, I don't think it will, because of the fact that the things that are monitoring the code have the same flaws as the things that are writing the code. I mean, we saw that the code that was, the AIs that were deploying code started deleting environments, even though they're told not to. Well, they weren't the ones writing the code necessarily. They're the ones that were modifying the environments, and yet they were deleting databases. So it's not like this is only a coding problem. This is an AI problem. AIs have a negative impact on our software in the entire stack. So more code is entering into production with no review at all. And no, I don't think the solution is to have another AI in the process. Number 9, strong engineering foundations do not protect you. This is a fascinating element of this report. 2 years of telemetry says so. So they have looked at the logic is, well, if we have strong practices, if we have a team that is really good at being great software developers, and so we just empower them with AI, that those strong practices will override the AI's mistakes, and it will make sure that we have good systems in place. Microsoft has good systems in place and good processes and good review processes. And they have had a horrible 2025 because their software broke a lot. And even their fixes for their software broke more things. And GitHub has great processes and they're falling apart. The Amazon has great processes and yet they're falling apart and they have production issues. Just because you have a strong engineering foundation doesn't mean that's a protection against what AI can do in your environment. So that to me is a clear wake-up call that there's not just a easy solution of, oh, we'll establish good practices. What we found is that actually the more AI is relied on, the weaker the development environment gets. Because, yeah, at first you have those strong practices, but over time you start to slip. And the more code is being put into production, the less you're reviewing it. You just don't have time. Again, that's point number 8, where the more code is going in production without review because you just don't have time. And so the more you accelerate, the more you push AI to do more, your engineering foundations just erode and erode and erode, and it causes more problems. So that's the AI acceleration impact report. Let's talk about the Engineering the Age of AI report. This is a benchmark report. In this, by the way, how engineering leaders are navigating the AI revolution, what they're learning about the hidden cost of speed. Hidden cost of speed. Now, in their report, they said that is up 2% the pull request success rate, up 9% in cycle time, up 20% of pull requests per author, but yet incidents, again, per pull request was up 23%, and the change failure rate was up 30%. So this is actually, my highlights are a little bit off here, but this is the productivity paradox. AI makes developers faster, but the increased velocity creates downstream challenges that erode the gains. Developers ship more code, but that code introduces more bugs and stability issues. So for every pull request merged, teams are seeing nearly a quarter more incidents compared to a year ago. Again, this is a recent report. This is a 2026 benchmark, which means that it's using some more recent models, some more recent tooling, and they have years experience probably in most cases of working with AI. And yet this is what we're seeing. Incidents are increasing, more bugs, more stability issues. So this is also from that report, engineer leaders report that resolution times are increasing. And why is that? It says when systems fail, teams are taking longer to restore services compared to before widespread AI adoption. So think about that. The number of incidents have increased from a couple a year to weekly occurrences in a lot of cases. And we've seen that the percentages per pull request are going up and the pull requests themselves are going up. Therefore, we have a lot more issues in production. And yet those issues are taking longer to fix. So outages are taking longer to restore compared to before AI. Why? Well, the increased complexity of AI-generated code makes debugging harder. AI writes bad code. It's complex. It repeats code. It causes all kinds of issues. So engineers respond to problems often encounter code they didn't write and don't fully understand, even if they or their teammates originally submitted it. So they're submitting code they don't fully understand, so when it breaks, they don't know why. This is something I teach at the very beginning of like the C# master course, when I teach in the classroom. It's one of the first lessons I teach, and that is magic is a problem. If you're a software developer, you shouldn't be relying on magic, because when the magic breaks, you don't know what to do. This is why in my classroom, I had a book that I taught at the college level, and the first chapter was a final new project for a WinForm app. And you drag and drop a button on there, you click the button, you make it say hello world or hello your name, and you're like, wow, I've got an application that works. The problem is all of that is magic. You don't know how the form works, you don't know how the button works, you don't know how the event works. And so if something goes wrong, you don't know what to do. In fact, there's a demonstration I do where I delete the event handler code from the code behind. And I say, okay, let's just delete that. Then the editor itself won't render the form. It gives us this yellow error message. And I'd ask my students who come from other classrooms or come from trying on their own, and I'd say, what do you do in that circumstance? And the answer, when they learned as magic, was I delete the project and I start over. because they didn't know how to fix the problem because they didn't understand the underlying system. Well, here it's saying that resolution times are increasing because one of the reasons is that engineers don't fully understand the code they're trying to debug. So the higher volume of changes and deployments creates more potential failure points, making root cause analysis more time consuming. So it's harder to find out the problem because there's also more moving parts, more things in more places. The cost in lost revenue, customer trust, and team burnout compounds with each problem. Again, remember, the problems are accelerating. And with each problem, lost revenue, customer trust, and team burnout just compounds. I think that's a really important point to understand is it's not just that the code broke. It's that what does that do to your team? What does that do to the people on call that have to support that and have to support more and more outages every single week? What does that do to your customers and their trust in your product? So, and then eventually, what does it do to your bottom line? What does it do to your actual income when your customers don't trust you and when your app doesn't actually run and you're having to, pay out for service level agreements that you failed on? These are all major problems. All right, let's look at another section from that report. This is our developers forgetting how to write code, which I think is a real big issue. So the concern isn't just about individual developers losing skills. It's about organizations losing institutional knowledge and the ability to maintain and evolve their code bases. So they don't have the institutional knowledge. The next highlight down here, this is unwritten knowledge. The why behind the what is essential for debugging complex outages and planning long-term architectural changes. This is where the wisdom and knowledge of that long-term senior developer used to be such a big deal because they didn't just know what the code did. They also knew why it did it that way, why they didn't do it a different way, why it works the way it does, and then what you cannot do to change that software and what roadblocks you're going to run into. But when you don't understand how the code works, when you don't understand the architectural decisions that went into it, what you have is a shaky house of cards that is going to come down if you just poke it a little bit too much, which means it's a more and more fragile artifact. Shipping code, that's the next highlight, shipping code without this deep context ultimately builds a brittle system, that house of cards. It may function correctly today, but it becomes nearly impossible to safely evolve. I think that's a really important sentence to understand. It may function correctly today, but it becomes nearly impossible to safely evolve. This, I think, is one of the big dangers around AI doing anything, is that in the short term, it looks great. In the short term, we see that acceleration where we're getting more code, more tasks being complete, more code being written, more pull requests being completed. And we say things are good because we're getting more done. The problem is that we're creating a brittle system that may function correctly today, although we're seeing more and more problems, but it becomes nearly impossible to safely evolve. We're building a house very quickly without blueprints, or we're just throwing up new rooms, and we don't have the good foundation to build upon. We have this rickety structure that is a house, but at some point it's going to come collapsing down. It's just not today. And that's the scariest part, is if it collapsed right away, we'd undo it. But if it doesn't collapse right away, we keep building on it. And eventually have this big system that is going to collapse on its own weight, but it's a long-term investment. We can't just roll back now. That's super dangerous. So this is AI, how AI hurts software. But the question is going to be, what can we do about this? Because AI feels inevitable. And you may work at a company where you're told you have to use it. And you have to accelerate how much you deploy. And you have to. Well, I would encourage you, first of all, share this video with your management team. I can bring potentially some credibility in a way that maybe you can't. I can say things that you couldn't say to your boss. And so hopefully, the bosses are watching right now and are really thinking through the fact that we don't want to build on a bad foundation. We don't want to create all these problems. But either way, if it's you or your boss, I want you to think about these things that you can do. Number one, establish and maintain good fundamentals. This is incredibly important. And you may say, well, I'm not allowed to have good fundamentals. You need to, as much as possible, push for those. But even so, you need working outside of work potentially to maintain your fundamentals, maintain your abilities. There will come a time when the software collapses. Microsoft is seeing that with Windows, where they're spending an awful lot of time and effort going back and undoing a lot of changes and fixing a lot of things that are broken because of the fact that they created this mess. And they're trying to undo and unwind things and yet still move forward. And at some point you may work yourself in a corner. Like even the largest and most, supposedly knowledgeable software development companies in the world are having this problem. Why wouldn't you? So you make sure that if you're a developer being told, I have to do it this way, still work on maintaining your good fundamentals. I liken this to going to the gym, where when, if you go to the gym and watch somebody else work out, first of all, it's kind of creepy. But second of all, you aren't actually maintaining your muscle mass. You're not maintaining your health. What you're doing is you're actually atrophying. Because even though you're at the gym, even though you're watching somebody else do it, your skills are weakening over time. You're not the one lifting the weights. So in the same way as a developer, if you just go into work and watch an AI do its job, your skills are going to atrophy. And no, code review is not going to build up those skills. Code review skills are great, but those aren't the same skills as development skills. And you need to make sure you're working on development skills. Practice. It's important. Build things on the side without AI. This is where I'm encouraging people right now that, people say, I'm just so, frustrated by AI. I'm so burned out. I don't want to write software. I don't want to go home and write software because it's just, it's more the same. I get tempted to, use Copilot or Claude at home and, it's just more the same. I would encourage you, find a way to make it fun again. Find the fun in software development. I just completed a master course in Unity with C#, and that's a lot of fun. You get to write code. We didn't use any AI in the course. You get to write a lot of code and see it actually create a game out of it. And you can have a lot of fun with that, even if you're not a game developer, even if you're not going to be a game developer professionally. Just build something fun with code again. Get back that feeling of joy around writing code and seeing your code actually do something, and maybe getting it out of the, doing things in the corporate environment might help. Now, it's not the only solution. I think you need to still be writing good code and still be practicing corporate code or, line of business application code or, potentially the boring code. You still need to be doing that. But there's also a case for kind of refreshing your brain a little bit and just getting out and writing some fun code as well. Number two, focus on quality over speed. Again, I know that management's going to push back on this, but this is where senior developers, your job has always been to not just write code. In fact, senior developers write less or should write less code than the mid-level developers, because your job is more keeping an eye on the overall product, guiding people lower down, the skill level than you, guiding them and lifting them up and trying to overall set the focus and direction of your code and of your organization. And part of this is monitoring how your code is operating, how the bugs are your bugs increasing or decreasing? Is there security problems? Review those things, etc. Well, right now, If you want to be a senior developer, or you are a senior developer, or it doesn't matter where you are on the totem pole, you have the tools to be a senior developer. So work on evaluating the code that goes to production. Talk to your boss and say, hey, we rushed these 10 things into production and 8 of them had flaws. And now we're rushing to fix those 8 flaws instead of pushing them out more slowly and being more cautious and more quality focused. So have that conversation. And you know what? You may get pushback and say, we don't have time for that. Just rush forward. And so that's fine. Have that conversation though, because next time when you push those 8 fixes into production, you say, we pushed 8 fixes in production. We had six flaws in those fixes. They were based upon the 8 flaws in the 10 fixes. Like, start to show that pattern of we're fixing things over and over and over again. And really establish the idea that, we don't have time for quality. And maybe start saying that. It sounds like we don't have time for quality. And if your boss pushes back and says, no, you have to have quality, well, then we need to spend more time. It can't be both. So we either need to spend more time or say that quality isn't quite as important. That's what it really comes down to. Number 3, learn how AI actually works. This is one that I think that's important for people whenever they're dealing with AI, to actually understand how AI works. And people say, well, I know how it works. I ask it things, it tells me things. That's not what I'm talking about. I want a deeper level to truly understand, how does it make decisions? Because when you start to understand how AI actually makes decisions, you start to realize you shouldn't be allowing AI to make decisions. That's really important. You should be allowing AI to write code. That's fine. I actually don't have a problem with AI writing code to an extent. But what you should be doing is not allowing it to make decisions. You should be the one making decisions and telling AI how to write that code. So I create a whole course on this. If you're a DevPass member, you have access to it for free. If not, you can buy it on imtimcorey.com or buy the DevPass, whichever, or rent it. It's a rental kind of thing. But I have a Navigating AI course, and there's no code involved. It talks about how AI works, how it's built, how it's trained, what the different models, how they work. And yeah, models have changed and come and gone, but the reality of how AI actually works has stayed the same. And people may say, well, AI is smarter now. Yes and no. Because in some ways they create better output sometimes, but at the same time, again, we've seen that things are accelerating. Problems are accelerating with AI, not decreasing. So if the models are smarter, they should be decreasing the number of problems, not increasing. So learning how AI works will help you make wiser decisions about how to use AI, when to use it, when not to use it, what to use it for, what it's good at, and what it's not good at. You wouldn't ask an employee to do things that they're not good at. So why are we asking AI to do things that it's not good at? So learn how AI actually works. And number 4, adopt a turtle as an office mascot. Maybe get a stuffed turtle and put it in the office. And you may say that sounds stupid. We've had rubber ducks in our office for a long time as developers, because we have this concept of when you talk to a rubber duck, you're talking out loud about a problem. Sometimes just talking out loud solves the problem. It's not the rubber duck that's its solution. It's just a stand-in for us. Well, maybe do the same thing with a turtle, where you talk to the turtle and say, this is what we're planning on doing, and think about how a turtle would respond. We have the slow and steady wins the race mentality. We should have that. We've forgotten about Aesop's fables and the idea that the tortoise and the hare, and the hare blasts off in a race and the tortoise just plods along. But at the end of the day, the tortoise is the one that wins the race. And that's where we're at with AI. Right now, we are the hare. We're letting the AI be the hare. It takes off and it just goes crazy. But then it gets distracted. We know that. And it goes off course and we have to backtrack and we cause all these problems. And meanwhile, the slow and steady, it is plodding along and it's going to beat us down the course because we thought that speed was the solution. Speed's not the solution. The solution is to be slow and steady, to have good quality, to establish and maintain good fundamentals. So maybe adopt a turtle as a mascot. Okay? So that's how AI hurts software. This is part of an overall series on how AI hurts everything. This is really not about causing AI, saying AI is horrible and that AI should go away. I think there might be an argument for that. But I think the bigger argument is that whether or not you use AI or how you use AI needs to be informed not just by the positives. When you see things like 33% more tasks completed per developer, you say, that's great. That's what AI brings to the table. But what you're doing is you're looking at only the positives, not at the negatives, not at the drawbacks of that additional speed. And I want you to have an understanding of both the positives and the negatives so you can make a wise decision based upon all the facts, not just a rosy view of life that's going to leave you with a brittle architecture that is prone to failure. So I want you to think through the positives and the negatives. Look at that list of things that we can do. Start thinking about how to make improvements so that you're not caught up in the problems of AI and your software isn't one hurt by AI. Thanks for watching. And as always, I am Tim Corey.